Welcome. This is part 3. We are dealing with cos compound and sine compound. Now, before we begin, let us do a recap on the expansions of cos compound. So, the sign changes. The pattern goes cos, cos, sine, sine, A, B, A, B. Cos, cos, sine, sine, A, B, A, B. If you had a minus, it becomes a plus. If you had a plus, it becomes a minus. What about the sine compound? We have the pattern goes sine, cos, cos, sine, A, B, A, B. The sign stays the same. If you were moving from the expanded form to the compound form, the sign will also stay the same. But what about cos? If you were moving from the expanded form to the compound form and you had a minus, it will become a positive. So let's solve. Let us see. We have sine of 280 degrees multiplied by cos of 160 degrees minus cos of 100 degrees multiplied by sine of 200 degrees. Now this looks like a mess, right? Because you have four angles that do not match up at all, so you can't have A, B, A, B. It is actually A, B, C, D. So we need to make them into A and B only. What about the pattern that the trig ratios form? We have sine, cos, cos, sine. So that's our cue. We need to follow the pattern. We have sine, cos, cos, sine. This pattern resembles that of the sine rule. So we're going to use the sine rule to compound this problem. This is how you need to approach these problems. You see, you have 100 degrees, right? And then you have 280 degrees. In your mind, you need to think of these angles and 360 degrees. Now, what would happen if you add 180 to 100 degrees? You will get 280, right? That means we need to reduce 280 degrees by using 180 degrees. So let's do that. We have sine of 180 degrees. From 180 degrees, you need to add 100 degrees to get 280. So we have 180 plus 100 degrees. So we have just expressed 280 in terms of 180 and 100, so that we can use 180 to reduce this angle to 100 degrees. Multiplied by, now cos of 160. 160 should correspond with 200, right? Because this is sine, cos, cos, sine. This corresponds with this, therefore these two pairs are left out, so they are so they should correspond. Now when I look at 200, you only need to subtract 20 degrees to get to 80. And when I look at 160, I need to add 20 degrees to get to 180. So we are going to use 180 to reduce 160 to get an angle of 20. And we are also going to use 180 degrees to reduce 200 to get to 20. Here's how it's done. So we have cos of 180 degrees. You need to subtract 20 degrees from 180 to get 160, right? Minus, we leave this as is because it will match the angle. The angle of 100 will match up with this angle. So we have cos of 100 degrees multiplied by, we are reducing sine of 200 by 180, right? So we're having sine of 180 degrees plus 20, because we need to add 20 with 180 to get 200. So we have, let's do our cast on the side. So we have 180 plus, that's the third quadrant, right? And sine is negative, so we'll be having negative sine of 100 degrees multiplied by cos of 180 minus, that's the second quadrant, and cos is negative, so we'll be having negative cos of 20 degrees minus cos of 100 degrees multiplied by sine of 180 plus, that's the third quadrant, and sine is negative, so we'll be having negative sine of 20 degrees. So what we have here is we have a negative multiplying with a negative, so we'll be having a positive pair of trig ratios that are multiplying each other. So we'll be having sine of 100 degrees multiplied by cos of 20 degrees, and here we have negative multiplying by negative, so we will get a positive cos of 100 degrees multiplied by a positive sine of 20 degrees. Now look at what we have. We have sine, cos, sine. So the trig ratios match up with the pattern of the sine compound, right? What about the angles? We have 100, 20, 100, 20. So A, B, A, B. So the angles are corresponding. 100 of sine corresponds with 100 of cos. 20 of cos corresponds with 20 of sine. So we will be having sine of 100 degrees. But since this is sine rule, the sine doesn't change. So we'll be having 100 plus 20 degrees. Now this is where most people would panic, because just by looking at it, you can see that we are going to get an angle of 120 degrees, and it is not a special angle. It is not 180, it is not 90, it is not 360. But this is trigonometry, guys. We need to apply what we always learn from the previous exercises. Like in grade 11, we were taught how to reduce angles. So sine of 120 can be reduced using 180. So you shouldn't panic when you see something that you have never seen before. We have sine of 180 degrees. Now, what do you need to do to 180 to get to 120? You need to subtract 60 degrees from it, and 60 is a special angle. You see where we are going. So we'll be having sine of 180 minus 180 minus is in the second quadrant, and sine is positive, so we will have sine of 60 degrees. Now 60 degrees is a special angle. We are allowed to put this into our calculator or to remember what it represents. So we have square root of 3 divided by 2. Now, how do we know that we got our answer correct? Well, we need to go back to the problem statement and put the whole thing into our calculator. So we have sine of 280 multiplied by cos of 160 minus cos of 100 multiplied by sine of 200. The answer that we get is 0,866 blah 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 blah. You shouldn't panic when your final answer doesn't look like the answer that you used to check, because when you divide square root of 3 by 2, you get the same number. So yeah, this is correct. Thank you for watching.